Okay, so to sheet 6, question 1. Solve each of the following inequalities. A, -2 less or equal to 5 minus 3x over 4. This is less or equal to half. So I'll ask all of you to mute and only unmute when you have a question. Okay, so we can continue. So if you have a constant in the denominator of any part of the inequality that you're dealing with, you should feel free to be able to cross multiply and get rid of that constant from the denominator, because it does not affect anything. So in this case, we'll multiply throughout by 4 so that we get -8, which is less or equal to 5, minus 3x, which is less or equal to 2, because half by 4 you get 2. From there, we are now supposed to get rid of the 5. So we'll have -8 minus 5 less or equal to -3x, which is less or equal to 2 minus 5. From there, we will have -13 less or equal to -3x, which is less or equal to -3. We want to get only the values of x. So we divide by -3, we divide by -3, we divide by -3. When you divide by negative, the inequality will change. If you had less or equal to, you will have greater or equal to. If you had less, you have greater. So in this case, we're going to have 13 over 3 greater or equal to. So the inequality there will change. We have x here greater or equal to 1. So to present your answer well, you say you start with the smallest and end with the biggest. So you end there because there's nothing more to simplify. So that if we have something else like b, where we have 2t squared minus 9t minus 5 greater than 0, what you have now here is another inequality, but on the left we have a quadratic equation, which is factorizable. Hello?
Hello, sir. Since we have already solved some of these questions, can we just proceed from where we have stopped?
Okay, I didn't know that you had solved some of Tiroshi's 6 questions.
The same question 1. You had solved up to question number 1C.
Now, this is a different group, so you must be belonging to both groups.
All right.
Okay, so we have 2t squared minus 9t minus 5 greater than 0. The quadratic on the left is factorizable, so we'll have to factorize it. And if you do so, you have 2t squared minus, okay, here there'll be plus t minus 10t minus 5 greater than 0, because if you multiply 2 by -5, you get -10. Then your sum will be -9, so your factors will be 1 and -10. so that you factor out t here and remain with 2 plus 1. I mean 2 plus 2t plus 1. And then you factor out 5. Again, you have 2t plus 1 greater than 0. And this is going to give you 2t plus 1 and t minus 5 greater than 0. Then, in this case where you have a product, you get what you call the critical values. These values are neutral in terms of signs. When you substitute them in your expression on the left, the values won't tell you if they are greater or less than 0. So we get 2t plus 1 and equate it to 0, so that we get t is equal to negative 1 over 2. We also get t minus 5 and equate it to 0, so that we get t is equal to 5. Now we have options. You can decide to use a table, or you can use the number line. So I'll use a table. So a number, so here we need to pick a number in between negative half and 5. The easiest number to use here is a 0. So we can pick a 0. The number bigger than 5, we can pick 6. The number less than negative half, we can pick negative 1. And then bring down 2t plus 1 and also t minus 5. And then we'll have the product 2t plus 1 and t minus 5. So we're interested in the signs now. When you substitute negative 1 in 2t plus 1, so you're going to have 2 by negative 1 plus 1, so you get a negative 1. So you get only the negative because you can choose to use different numbers. But the interest is in what sign are you going to have? Is it greater or less than 0? If it's less than 0, then you show that by putting a negative. If you take to the t minus 5, again we get a negative. If we multiply these two, since they are multiplying here, you get a positive. So you keep the positive. When you substitute 0, you have a positive here, and you have a negative here. So that if you multiply, you get a negative. When you use 6...
Excuse me, sir.
Okay.
Excuse me, sir. Can you be writing what you are saying, because the network is breaking? So if you are just, some of us are hardly getting it. So at least if you be indicating everything that you are saying.
Okay.
Thank you.
So when you substitute 6, you have 2 by 6 plus 1, which is 13. And 13 is positive. So we use a positive there. Then you also get t minus 5 and substitute 6 there, so that you get 1. The interest is in the sign. This number is positive, so we bring it there. And then positive by positive, we get a positive. So we have a positive here. Now, the inequality here is asking us to find where it is greater than 0. So we want where it is greater than 0. That is this part and this part. So to present a solution set, we'll say the solution set is going to be from negative infinity all the way up to negative half. Union, because you're skipping an interval, 5 all the way up to positive infinity. That will be the solution set. If you pick a number in here and test, the inequality to be will hold. So if we don't have any question, you can move to the next part. C, we have x minus 3. We have 3x plus 2. And we have x plus 4 less than 0. This one is already factorized. So it's starting from this point, where our next step will be to get the critical values. X minus 3 is equal to 0, implying that x is equal to 3 is a critical value. 3x plus 2 is equal to 0, implying that x is equal to negative 2 over 3 is a critical value. X plus 4 is equal to 0, implying that x is equal to negative 4 is a critical value. I go back to the table. Negative 4 is the smallest, negative 2 over 3, and then 3. Again, I pick a number that is bigger than 3, that is 4. Because we can't test using 3, negative 4, negative 2 over 3. If you use these numbers, we won't know which part of the real numbers gives us a positive or a negative of this expression. That's why we're using the numbers outside these 3, negative 2 over 3, and negative 4. So you pick a number bigger than 3 to represent the whole interval after 3. We also pick a number in between negative 2 and negative 2 over 3 and 3 to represent the interval in between these two numbers. So here you can pick a 0. It's the easiest number to use in that interval. And here you can pick negative 2. And then you can pick negative 5. You can pick any other numbers for as long as you're able to extract the signs that you're interested in. And then we pick the x minus 3, 3x plus 2, x plus 4, and the product. Then from there, you start now testing. When you bring negative 5, you're going to have negative 5 minus 3, which will give you negative 8. You're interested in the sign, so you put a negative there. Again, 3 by negative 5 plus 2. Again, you get a negative number. Negative 5 plus 4, you get a negative number. If you multiply negative by negative by negative, you'll get a negative number. So your result is negative. You go to negative 2. For negative 2, we'll get a negative number there, negative 2 minus 3. Then you go to 3 by negative 2 plus 2. Again, you get a negative number. Then negative 2 plus 4, you get 2, which is positive. When you multiply negative by positive, you're going to get a positive as a result. You go to 0, it will give you a negative number there, a positive here, a positive here, and the product will be negative. You take 4, you have positive here, positive here, positive there, and the product is positive. Now the interest here is we want to check where the expression on the left is less than 0, which is this and this. So the solution set, therefore, is going to be negative infinite up to negative 4, union negative 2 over 3 up to 3. So this will be the solution set. These are the only intervals where the expression on the left will be less than 0.
Excuse me, sir.
Okay.
So when writing the first interval negative infinity, comma negative 4, I was asking if why we never ended at negative 5, negative infinity, comma negative 5.
Because someone else here could have picked a number that is less than 4. Even negative 6 is less than 4. But they could not end at negative 6. They have to go up to 4. The idea is negative 4 is the boundary. And less than negative 4, negative 5 was just a representative. We could have used any other number there. Even negative 20 still falls in that interval. Even negative 100 falls in that interval. So you could use any number to test, for as long as it's less than negative 4, but your boundary will be negative 4.
All right, thank you, sir. And another, sir, the first question that we did, we never used critical values. Then these others, we've been using critical values. So how can I detect that this one uses values or this one just go direct without using critical values?
So in this case, there's even no room for critical values.
How can you tell that a question to be
The interval itself will tell you that now I need a critical value or not. Because if you have this situation here, no need of any critical value. But if I have this situation here, t keeps on changing. So as t changes, it will be affecting the whole expression on the left, depending on the values of t. But if I have constants surrounding a variable, what you are saying is that the variable has been restricted to only 4 in the given interval. So you don't need anything else to test where the variable must be. You have already guided. So the variable must be between 1 and 13/3. But if you have such a case, you don't know what to say. Where must t lie for you to get this greater than 0? It's only after you have tested for you to know that, oh, okay, so this is going to lie in this interval for me to get my expression to be greater than 0.
all right, thank you so much.
Okay. So if we have no other question, we can move to D. Less or equal to 2. Now when you have this, we have a constant on the other side. On the other side, we have a fraction involving variables both in the numerator and in the denominator. That means that you cannot cross multiply a variable. We can't do that. So because we can't do that, then we'll be forced to get the 2 from there and bring it on the left. And then we get a common denominator and have this to be less or equal to 0, which then becomes a minus 2a Just a minute. Okay, so a minus 2a minus 1 plus 10 over a minus 5 less or equal to 0. What does this become? This becomes negative a plus 9 over a minus 5 less or equal to 0. Then from there you get the critical values. The critical values, you have a is equal to 9 and a is equal to 5. Then you test. 5 is smaller than 9, and we have 6 in between these guys. We have 10 bigger than 9, and we have 0 less than 5. And then we have negative a plus 9. We also have a minus 5, and we have the whole quotient. So we can test. So I can even do this where I block the intervals like that. Okay. And then you start testing. So say if I take 0 there where there's a, we'll have 9, which is positive. You take 0 where there's a, you have negative 5. So the product here, the quotient sign is going to be negative. We know that the positive over negative is the same as negative. So when we take 6, again we'll have negative there. We'll have positive, because it will be negative 6 plus 9, which is positive. And then 6 minus 5 again, positive. When you multiply, you get positive. Then 10, you have negative, positive, negative. We're interested in the region where the inequality is less than 0 from here. So it must be less than 0, and so our solution set is going to take these intervals. So the solution set is negative infinity to 5. Because it's less or equal to, the numerator will be included, meaning this. The denominator won't be included, because if you try to include the denominator, you have a 0 in the denominator, which makes everything undefined. So because 5 is also in the denominator, we won't include it. Union 9 will be included all the way up to infinity. Because even if we include 9, when we put it here, we'll have negative 9 plus 9, which is 0. And this is less or equal to, so it's starting from 0. So there's no harm in doing so. So that will be our solution set for this kind of question.
Sir, I have a question.
You can ask.
What's the reason you gave for not including 5 in the solution set?
If you include 5, what you mean is that you can substitute 5 there. That is going to be negative 5 plus 9 over 5 minus 5. This will be 4 over 0. And you don't know what this value is because it's undefined. So then it makes sense to include 5.
So you can't include it.
So you can't include it. But for 9, we can, because 9 is in the numerator. If we include 9, you're going to have negative 9 plus 9 over 9 minus 5. This is 0 over 4, and we know it is 0. So there's nothing wrong. Yes.
Suppose the inequality sign that we had was just less than, would we have included 9
No.
on the solution set?
Just like we did here. We just had less than, so we could not include any boundary.
Oh, okay.
So you only include a boundary if you have less or equal to, greater or equal to. And the only boundary that you include are those that are coming from the numerator. So you go to E, 1 over x minus 2 is greater than 1 over x plus 3. So again, these are fractions with variables, so we can't cross multiply. What do? We put them together, greater than 0. Get the common denominator, and do the subtraction. So you have x plus 3 minus x minus 2 greater than 0, implying that we have x plus 3 minus x plus 2 over x minus 2 x plus 3 greater than 0. This implies that on top we only have 5 and x minus 2 x plus. Okay, so let's log out and log back. Let's log out and log back quickly.